In this video, we're going to go through how to set up a new Helios project. I'm going to be using CLion and a Linux system, but the process should be basically the same whether you're using a different IDE or the command line or on a different operating system. I'm going to assume that you already have watched the previous videos on how to install Helios. So I'm going to assume that you have the Helios source code already checked out from GitHub, and you're able to run the sample projects successfully. We'll cover two different approaches for creating a new project. First, we'll just show how to manually copy a sample project that already exists and then modify it in order to create your new project. I'll also show you a bash utility script that is included with Helios that makes setting up new projects very quick and easy. Once we've created our new project, I'll take you through the typical project directory structure and what it contains. This includes a cmake list.txt file that tells the compiler how to set up and compile the project. Then usually we have a CPP file that contains our main routine. Usually we call this main.cpp, but it could be called anything. Then we have a build directory where we're going to actually configure and build the project. This is going to contain the executable that we eventually run. And then I'll take you through developing a very simple main routine so that we can get an idea of what that typically contains. So here I have open CLion. I have Helios already checked out from our GitHub repository and loaded into CLion. And I've already verified that I'm able to run different test cases. So what we want to do here is to set up a new project. And we have this folder here that we haven't really dealt with yet. That is where we usually put our projects. In theory, you could put this anywhere, but this is the usual place that we put it. So there are a couple of ways that we can create a new project in this directory. One is that we can just take one of these sample directories that already exists, and we can go ahead and just copy it into our projects directory and then modify it based on our particular application of interest. So in this project that we're going to develop, we're going to use the visualizer in order to just do a very quick visualization. So we could copy over any of these sample projects and then add the visualizer to it, or we could just find a sample project that already includes the visualizer. So I'm going to do that. So I can right click here and then go to copy. And then if I go onto my projects directory, right click again and then go to paste, then it will bring up this copy dialog. So it's going to ask you what you want to name the copied project or directory and where it's going to put it. So I'm going to call this project, my project. You could name it anything. And then if I click OK, it'll probably automatically ask you if you want to add these to Git. I usually don't add projects to Git. The Git part is just source files and the core Helios files. So I can just hit cancel to not add it. Okay, so now we have this directory structure that we just copied over. It contains three basic elements. One is going to be a directory called build. This is just an empty directory. This is where we're going to configure and run our project from. Next, we have this cmake list.txt file, and this tells Cmake how to configure your project. So let's go ahead and open that up and go through the different pieces. So this first part is just a header. It specifies some required version information and then gives the project a name. You don't need to change any of this part. You'll just leave this as it is. Then there's a section that's labeled with user inputs. These are the things that you would typically change. Basically, all this does is it allows you to set a few variable values, and then it calls this other Cmake project file that is what actually does the configuration and makes this Cmake list file do something. So the 4 different variables that we can set here are first the base directory. So I mentioned that we could, in theory, put our project anywhere that we want on our system. The key there is that we just have to reference back to where the base Helios directory is located. So if we put it here in this normal place, which is under this project subfolder within the Helios directory structure, then the base directory is just 2 directories up. So one directory up is going to be the projects folder, and then the next directory up is going to be the main Helios folder. So that's where we want to reference. So we can just specify a relative path, which would just be ... and ... which means to go up 2 directories. We could also give it an absolute path if we wanted to here, but it just needs to reference this main Helios directory. 99% of the time, I just put the project in this projects folder, and then this never has to change. It's just 2 directories up. The next variable is called executable_name, and this is the name that the executable is going to have that will be created once we compile the project. So for this previous project that I copied over, it was called visualizer_self-test, but we probably want to give it a different name here because we're no longer going to be running that case. We're going to set up our own. So I could call this my project or my executable or something like that. We'll just call it my project. And we'll just remember that because once we run, that's going to be the executable that we want to run. Next is the variable called source_files. And these are the source files or .cpp files that you want to compile with your project. And so we always have one file that contains our main routine. In this case, it's called main.cpp here, but it could be named anything that you want it to. We just need one file that's going to contain our main routine. And then if we had other CPP files that we wanted to make within our project, let's say that you are defining a lot of custom functions or something like that within your project, and you want to put them in a separate CPP file so that your main file doesn't get too cluttered, then you could add multiple files by just separating them with a semicolon, so some other file, .cpp, etc. If your project also has custom header files, then you'll notice that there's no place to specify that. You'll just want to put that in your project directory, and then it will automatically look there to find the header files. The last variable is called plugins, and these are the different plugins that we want to use with our project. So this could be left empty, in which case it won't load any plugins. Otherwise, we can specify the name of the plugin here that we want to include. If we have multiple plugins, then we will want to separate that with a semicolon. So how do we know what the name is of the plugin that we want to put here? There's 2 different ways we can figure that out. One is that if we go to this plugins directory, you're going to have a list of all the plugins available. And so the name that you want to put here corresponds exactly to the name that's listed here in this plugins directory. So visualizer here, we've got visualizer there. The second place we can find those names is in the Helios documentation. So I've gone ahead and opened up our Helios documentation. This is at baileylab.ucdavis.edu/software/Helios. And if we go to the plugins tab here, it lists all of the different available plugins. So in this one, we're going to be using Visualizer. So if I click on that, you'll find that they always have this little table or box at the top. And it's going to tell you exactly what you need to put in your Cmake list.txt file in order to use that plugin. So you'll notice this is exactly what we typed here in this plugins variable. And again, if we wanted to include multiple plugins, we would just add a semicolon and then type multiple plugins after, and then it would load all of those. Okay, so that's pretty much it as far as our Cmake list.txt file goes. The last thing we want to talk about here is our main.cpp file. I'm going to first just go ahead and load this project so it gets rid of all of these warning messages. So again, we right-click on our Cmake list.txt file, click load. You can go ahead and click on your Cmake tab down here just to verify that it finished and it wrote all the build files. Now we'll also notice that some things changed. Our build file now contains a bunch of configuration files and directories. You'll notice that our Cmake list and our main.cpp file have these little blue squares next to the icons. That indicates that they were loaded as part of this project. You'll notice in this main.cpp file, we have a main routine. So the main routine in C++ or in C is always called main. It's a function, and it always needs to return an integer. So we declare that it's going to return an integer, we type main, and then open close parentheses. This function can take arguments, specifically from the command line. We're not going to cover how to do that in this video, but you can find online or in future videos on how to do that. Here, we'll just have it accept void, so it won't accept any command line arguments. Then we have curly braces that contains the body of our main function. And then we want this usually to return some integer value that indicates whether it was successful or not. There are a few things at the top here. So usually we will include any header files associated with the different plugins that we are running. So how do we know if we're using the visualizer plugin, for example, what the associated header file is? So we can go back to our documentation once again. And you'll notice that in the same table at the top of our plugin documentation page, we've got what the header file is. So we can copy paste this exactly and put that in the top of our file where we want to use the plugin. So we've got our include visualizer.h. The other thing that you'll often find in a main file is using namespace and Helios. So namespaces are basically just ways of organizing different variable values and functions together as part of usually some type of package. So if you are a Python user, for example, this will be familiar to you, where you have namespaces, like if you're using NumPy, then you'll often give it a namespace called NP or something like that. And then you'll always reference functions or variables under that namespace based on that particular name. And the same thing goes in C++. So if you're using a lot of different libraries, then it's possible that you might have naming conflicts between those. So you typically put those within a namespace such that you don't get things mixed up, so that it's explicit how you're referring to each variable in a different package. And so Helios has its own namespace called Helios. But if I don't want to type that namespace every time I use a function or variable from that particular package, then I can just add this line called using namespace and then the name of the namespace, and it will just assume that anything that you type is from that particular namespace, and it will exclude any redundant names from different namespaces. So we usually have this at the top of our particular main routine. Another thing to mention while we're on the topic is that there's an additional header file called context.h. And almost any Helios program is going to use the context, but any plugin header file is going to also include the file context.h. So we could, if we wanted to, add this include context.h and it would give us access to everything in the context. However, this is already included again in the visualizer.h file. So if we're using another plugin, then we don't need to also include context.h, but we could. It's not going to hurt anything. That's all we're going to talk about for the moment. We'll come back and actually write ourselves a main.cpp file, but that's just kind of covering the overall basics. All right, so that was one more manual way to create a project. As I mentioned earlier, there is also a command line tool, a bash script, that will automatically create a project for you in a single command. And so in order to use that, the first thing that we need to do is create an empty directory where we want to put our project. So you could do that from the command line. You could come to your terminal here, and you could change into that projects directory, and you could make some project here by using mkdir. If you don't like using the command line, you could also just right click here, go to new, and then directory. So we'll use that approach. Let's call it my other project. And it will create an empty directory underneath this project's directory. Okay, so now what we want to do is to run the bash script. And so this is located in a directory called utilities. And it's the script called createproject.sh, which we can run from the command line. And so basically what we need to do is to run that script. So we could run it from wherever we are. We could basically go up one directory and then go to the utilities folder and then find that script. We could change into the utilities folder, and then we would do // and then that script. Or we could run it from wherever we want. So we'll just run it right here from the utilities directory. And then the first argument to this script is going to be the project directory that you want to create. So we created one in the projects directory. Okay, so we need to go up one folder, go to projects, and then we had my other projects. So it's going to create my project in there. And essentially what it's going to do is to set up this whole structure of the project for you. It's going to create a build directory, a Cmake list file, a main routine, all of that. And if I was to just hit enter here, it would just basically do a default project with no plugins added or anything like that. But I can optionally specify a list of plugins that I want it to create. So I could type visualizer, for example. I could type other ones like radiation or energy balance or something like that. You just need to separate them with a space. And so if I hit enter, then it's going to create a project in that folder. So if we expand that one, my other project, you'll see that it created an empty build folder. It created the Cmake list.txt file. And you'll notice it even automatically named my executable. It's just going to take the name of the directory as your executable name. So you could go back and change this if you wanted to. And then as you can see, it automatically added visualizer to our plugins list. So pretty much everything is set up for us and we are ready to go. It also created a main.cpp file. It automatically included the header that we need. It added this using namespace Helios, and it added this empty main routine. So it's pretty much got everything that we need in order to get going. So I'm going to go ahead and work from this my other project. I can load that to make all these warnings go away so that it's now part of the project. You'll see that it should get rid of all of this, and we get blue squares next to the files indicating that it's part of that project. Okay, so we should be good to go ahead and start making a very simple test project so that I can just illustrate what we would do next. I want to take this opportunity to just point out one additional feature of using CLion with Helios. So it allows you to have these smart templates where it will automatically write a bunch of code for you based on some template. And we've created several of those in Helios. We are continuously adding to them. So there's only a few currently, but I'll just illustrate that to write our code really quickly. So how you enable this is you go to your main menu, and then we go to File, and then go down to Manage IDE Settings, and then go to Import Settings. And it's going to ask you for a settings file to load. And so there is a settings file under the Utilities folder within Helios that we just explored a minute ago. And then go to Utilities, and then you have this CLion Helios settings.zip. Click on that, and then go ahead and load. And click OK. So it's going to ask us to restart once we do that, but that's not a big deal. And it should remember everything that we had already done. Everything's already loaded and ready to go. Okay, so all we're going to do in this project is to load in a 3D model and then visualize it. So there's this directory called PLY, and it has a few PLY 3D models within it. It's got these sort of very well-known classical 3D models like the Utah teapot and the Stanford bunny. So we can load one of those. So we're not going to go through in detail the use of Helios in the context. You'll just have to follow along, and then in future videos we'll dive into exactly what we're doing here. But go ahead and type context with a capital C, and then context with a lowercase c, and then semicolon. If you're newer to C or C++, then typing that semicolon is going to be something that takes a little bit of getting used to, but you'll get it eventually. And then we just want to type context with a lowercase c dot, and then load PLY. And then we're just going to pass it the path to one of those PLY models. And so the golden rule of referencing files within Helios to always remember, and I'll try to repeat this as frequently as possible, is that file paths, if you're going to use a relative file path, are specified relative to the directory in which you're running the executable. So in our case, we're running the executable in the build directory within our project. And so if we want to get to this PLY directory in order to reference a file in it, then we need to go up one directory to get into the projects folder, and then go up another into the project folder, then up another directory to get into the projects folder, and then up a third directory in order to get into our main Helios directory. And then we can go into PLY and then reference one of these PLY files. So we're going to do // one time. That's going to get us out of our build directory and into the my other project directory. And then .. again, that's going to get us out of our my other project directory and into the projects directory. And then .. / again is going to get us out of the projects directory and into the main Helios directory. And this is where we'll find the PLY folder. And then let's go ahead and load Stanford bunny .ply. And then we're going to need our semicolon here. So that's going to load that model into the context. To verify that it worked correctly, we'll go ahead and visualize it. And we have one of these templates already for visualizing geometry in the context very quickly. So in order to access the templates, we type the exclamation point. And then if you start typing the word visualizer, then there's this template called visualizer_context. It gives some information about what that does. And it has this little kind of stamp icon to indicate that it's a template. So if we click on that, then it will go ahead and add a bunch of stuff in order to do a quick visualization of whatever's in the context. So we should be able to go ahead and find our executable in this dropdown. Don't want to forget this step. Again, we called our executable my other project. You'll also notice that it has a little play button as well as a debug icon. This indicates that it's an executable. So if we click on that, then we can just go ahead and hit the play button. It did give us a warning in our main function because we forgot to return something. So we can just return 0 here. That will make that warning go away. And it should bring up this visualization of our Stanford bunny. It looks very flat in this visualization because we haven't enabled any lighting or shading. Just for fun, if you want to enable that, you can add this additional line, type visualizer, and then dot set lighting model. And then we can type in visualizer with a capital V, 2 colons, and then lighting Phong to use a Phong lighting model, and then a semicolon in order to finish that line. So we could run it again, and we get something that looks a little nicer. It actually has some shading so we can see what's going on with the model. I'm using the arrow keys in order to rotate the view. Again, if you want to know more about anything that we've covered, you can go ahead and find the documentation. So this covers all of this and much, much more. It covers the different key combinations, how you navigate the view, all of those sorts of things. All right, and that is it as far as creating your own project. We'll cover how to use different plugins within your project, how to build more and more complex projects, but this is the basic idea on how to get started.